Okay, we're doing our first day of review for the final. This is pre-calc. We're talking about problem 6 in that packet. We handed out a packet to you called Pre-Calculus Topics for Semester 2 final exam. Do you remember the formula you need for arc length? If you don't have it memorized, I would start right now a list of things you should study the night before the final, like little things that can actually help you at the last second. Like, do you remember the arc length formula? If you don't know it right now, a week from now, expect you probably also won't know it. So make yourself a little list. Maybe the way you could do that if you wanted to is go to the very bottom of the page and like you could flip through your packet when you're all done and look for things you wrote at the bottom of the page. Maybe you want to actually have a separate sheet of notes where you write out, here are the things I should study the night before the final. All right, so S equals theta R is that formula. You remember that? SOAR, S equals theta R. And that is the arc length. Which one of these is the arc length? The S is the arc length. The theta, what's that? That's the angle. And the angle has to be in what? Radians. And that makes the R kind of confusing because it looks like it's radians, but it's not. It's actually radius. So if, for instance, you had a water skier, you got this boat here that is pulling a water skier who's back here, and they swing them in a loop around the boat because you can do that with those awesome jet boats. Come to almost a complete stop, spin them all the way around, and then keep going. It's a trick they do in the ski shows. So imagine for a moment that they had gone like that arc, and they said, well, we know how long the rope was. It was a 75-foot long rope when you just were told the radius. And then they might either tell you this distance and ask you what the angle was, or they could tell you the angle and ask you to figure out what the distance was. So let's say I tell you the angle, and I tell you the angle is that doesn't look like 200. That looks more like 110 degrees. Well, the first mistake answer that we would have in the in there would be to use 110 for the angle, because it's not. S equals not 110 times 75. How do I change it? I got to change it to radians, right? So how do I change 110 to radians? Yep, there's either, sorry, I didn't mean percent, 110 degrees. It's either 180 over pi or pi over 180. You want the degrees to cancel. I think you'd realize pretty quickly that you want the degrees on the bottom, so those will cancel. And then you could do some more canceling, and it'd be like 11 pi over 18. Then, if this was a test that would have answers that are, like no calculator allowed, then either these numbers would have been nicer, so they'd like cancel and stuff, or if they were like this would have been one of your multiple choice answers. Is it all multiple choice? No. There's some multiple choice, and there's some that are free response. Depends on the kind of problem. All right, so S equals theta R is our first big thing. That should help you with problems A, B, and C. How about number 7? Sine theta is equal to 1/2. Now this is important. What do the directions say? Find the angles that satisfies the given equation. Give theta in both degrees and radians. Okay. Do you remember how to even set these up? Yes, kind of. We need to make a triangle for this, right? Now, they did not give you that hint of find all of the answers between 0 and 2 pi. If they were doing that, then I'd be thinking, oh, we've got to look at all 4 quadrants. But to start with, do you get that if I have a triangle, I'll be able to tell, whether it's the 30, 60, 90 or 45, 45, 90? Okay, so sine of theta equals 1/2. Here's my theta. Sine is opposite over hypotenuse. There's the opposite. There's the hypotenuse. Can you tell by looking at that one which triangle we are in? Is it the 30, 60, 90 or the 45, 45, 90? 30, 60, 90. And that's this angle right here, or this side right there would be what? Square root of 3. Good. And what's across from the 1? 30 degrees. All right. If I was making a little list of things I'd want to make sure to go over the night before, I'll give you another thing on it. The 30, 60, 90 triangle. 1, 2, square root of 3, and 30, 60, and 90. If you don't have those memorized, you better make yourself look at it the night before so it's fresh in your mind. How about the other one that goes with that? 45, 45, good. And that's 1, 1, square root of 2. I'd make sure I had that memorized. And then was there one more way they sometimes do that 45, 45 triangle? They multiply them all by root 2. If they multiply them all by root 2, it turns into root 2, and this is root 2 times root 2, which would be root 4, which is 2. So there's another common triangle you got to know, okay? The list of things you better study night before. All right. Want help on 7b? Is that what you're saying? Or okay. I better finish this one, though, first. So what was the answer for number 7? It says find the angle, and it does say in parentheses S. Is there other angles that would have sine of theta equaling a half? Yes or no? There is another angle. There's another angle that 8 comes out to 0.5 or a half. Think about this. Sine looks like this. You remember how sine goes back and forth and back and forth? And what we're trying to find is sine of something where the answer would be a half. Here's a half. There's an answer here. There's an answer here. There's another answer over here on the next cycle, and another answer here on the next cycle. There's actually a bazillion answers that would give you a half. Remember this? So back to what Miss C said a second ago. All students take calc. All students take calc. Another thing on your list of things to study the night before the test, the ASTC deal. Okay, that reminds us that all of them are positive in this quadrant. Where is the other place where sine is going to be positive a half? The S quadrant. So there's another one right there. And that's where it's 1, 2, square root of 3, except this way. So how many degrees is that right there? Well, if this one right here is 30 degrees, then how much must this one be? 150, because the total all the way to here would have to be 180. So this one must be 150. So the answers are 30 degrees and 150 degrees, and then it also wants them in radians. You can change those to radians. Hopefully you have them memorized. If I was going to make a list of things to memorize, I would put this on my list. Yep, pi over 6 is 30. That's the smallest one we usually make you memorize. What's the next one? Next bigger one after 30. 45, and that's what? Pi over 4. What's the next biggest one you have to memorize? 60. And what's that one? Pi over 3. And what's the next biggest one? 90. And what's that one in radians? Pi over 2. And what else? 270, but 180's in there. Yeah, I think 180 is worth knowing. That's probably the easiest one. 180 is pi. Okay, what if we're around at 270, which is down there? 270 would be what? 3 pi over 2. And, of course, what's 360? 2 pi. All right. So for your list of things to have memorized, that's probably worthy of the night before. You can actually make a difference on this test the night before by having some of those things memorized. Given that we don't have that many days, I can't possibly go over every single problem we have done. There's no way. There's the physical time. There's not time to do every problem. We're not even close. So I'm just going to try to pick out the ones where I feel like with a little review you'd be all right. The ones that were insanely hard in the first place that you never really got in the first place, do you think you're going to get it right now when we only have like 3 days to review? I don't think so. Okay, so I'm not going to try to go over every single problem from the whole semester. That's not realistic. Yes, ma'am?
What is the thing where, like, it only works in, like...
Oh, that's for inverse trig. If you have inverse sine is of like 1/2 is equal to what? That kind of thing. On those inverse ones, the range of them, do you remember this one? That's another thing worthy of memorizing. Inverse sine is allowed from here to here. You remember that deal? What's the other one that's just like it? Inverse tangent is only allowed from here to here. Oops, not sine anymore, tangent. And then the last one is what goes from here to here? Inverse cos. Okay, and that I don't want to just try to bring up every random thing that you have to memorize between now and the test. But that's a good one. And those are the ranges. Do you remember how this is from pi over 2 to not 270, not 3 pi over 2? What do we put down here? Negative pi over 2. Good. If you're going to, oh, there's so many topics to know. So let's just kind of keep going through them in the order that we see them here. Look at problem 8. Do you remember the angle of elevation stuff? If you ever do angle of elevation or angle of depression, you should be starting with a horizontal line, and then if you're going to do angle of elevation, you're doing like this. That's the angle of elevation. And if you go the other way, be careful now. People oftentimes screw this up and say that this angle right here is the angle of depression, and it's not. This is the angle of depression. It's an angle that's going down from horizontal. Okay, so if I was standing right here on the edge of a cliff and I was looking down at a car that was down here, my car got pretty messed up, but anyway, this angle of depression, would it be A or B? Which one's the angle of depression? A. Angle A is the angle of depression. Very good. Okay, it's the one that's from horizontal. That's the angle of depression. Okay, you'll need that to answer problem number 8 and 9. Now let's flip to the next page, number 10. A ramp leading to the freeway is, okay, there's some multiple choice in this, but it's some free response. Yes, I did. I'm curious what you were thinking about at that time. Maybe you could review for us all the things you were thinking about since the beginning of class. I'm just kidding. Okay. No, we may not be able to publish that. Okay. Let's go to number 11. From the top of a 50-foot building. Oh, that's another one of those angle of depression kind of problems. So I think you can handle that from here. They would have answers that are left in the form of, like, for instance, sine 22 over 6 or whatever would be answer A. Because I know you don't know what sine of 22 is, you know. We will have answers that are not finished, I guess you'd say.
On here, do you want us to use a calculator to finish them, or just keep going?
You should not use a calculator for today at least, because I'll get you a final answer, but I'm pretty sure it's no calcs. Okay. Shh. Quiet, please. So let's move on to number 12. The length of a side of an equilateral triangle with an altitude of 5. All right. So that one you could do in a lot of different ways. You could use trig to do it, because since we're talking about trig, it's probably the logical choice. If they tell you it's an equilateral triangle, they just told you all the angles. What are they? They're all 60. Then, yes, kind of there's a 30 involved, because when you drop down this line, each of these then becomes what? 30. And so really you've got a 30, 60, 90 triangle right here then, don't you? And then if you've got a 30, 60, 90, you should be able to use trig to figure out if they tell us even just one side of it. Okay? And they told us that the length of side A, that's like this side right here, of this triangle has an altitude of 5. Oh, cool. They did tell us the height. The altitude is also known as the height. So they told us that side is 5. Now they've told us all the angles, and they told us one of the sides. If you have angles and you have sides, you can do lots of trig on that. So if I want to figure out A, should I use that angle and use sine of 60? Would that work? What's the opposite? Please don't talk now. Focus on this. Don't be intimidated by the fact it's a big packet. You have several days to do it. Okay, sine 60, sine is opposite of hypotenuse. Opposite's right there, 5. Hypotenuse is right there, A. 5 over A. If I was on a test where we were going to give you the answers without a calculator, do you get how to get A alone? Oh, wait, you can do sine of 60. That's one you can do. Okay, so you go off to the side with your little helper triangle. 30, 60, 90, 1, 2, square root of 3. And you say, what is the sine of 60? Sine is opposite over hypotenuse. Root 3 over 2. 5 over A. And see how that simplifies down? I can get the a alone now. I'm going to multiply both sides by a to get that a out of the denominator. That'll be good. Now, what else is in the denominator? Remember how to clear fractions like that? That's on this little top 20 you're going to be taking in a minute. All right, got to clear that 2 out of there, so I multiply everything by 2. And that'll clear that out of there. Now I'm left with a root 3 equals 5 times 2, and I'm almost done to get a alone. A equals square root of 3 divided on both sides, 10 over square root of 3.
Yeah.
That would be totally okay. But I do want you to understand that on a problem like this, for instance, 3 times 1/4 plus 5 times 3 over x equals 12, I'd want you to know how to clear that all at once. You times everything by 4x. Do you get that? Because that way, this 4 would cancel this 4. This x cancels this x. And now I've got 3x plus 5 times 4 is 20 times 3 is 60 equals 12 times 4 is 48x. And from there, that's baby algebra. You guys can obviously handle it from there. So I was just trying to multiply like that. Multiply by both the denominators to remind you of that technique. All right. So I think you've got enough practice problems there that you can keep going for a while without getting too stuck. I'll probably start helping you again with that on Monday. Now, we have most of this hour is taking that top 20, and or the other thing is, if you actually really want to take that cumulative on Monday, you have to have your corrections done. So we got to get those done by the end of the hour. So that's all I can do for review for today.